Well, I can't get my smart board to write. There we go. Notes on 5.6, tangent and cotangent. Alright, so with tangent and cotangent, let's look at the parent function first. And let's start with tangent of x. So the amplitude of tangent of x is 1. And we know that it doesn't reflect or move up, down, left, or right or anything when you have the parent function. But the period of tangent is very different from the period of the other 4 trig functions because it's pi divided by omega. And again, that is because when you go through the process, it just divides into pi because it repeats itself. So pi divided by 1 is pi. And then our scale factor will be divided by 4. And we've already stated there's no phase shift. Alright, so let's look at our table. Now, when you look at the graph of tangent, it's an odd function. And if you put it in y equals, this is the shape it has. So that means it's split on each side of 0. So you want to make sure you start your table without 0 being the first one. In fact, it's the middle one. And you're going to back up 2 lines on your scale factor instead of 1 line. So make yourself a note. Back up 2 lines. And then for the other side, I'm just going to give you the values. We could talk about the unit circle and go through and find them all. We've done that on the others, but just to save a little bit of time, it's undefined, -1, 0, 1, undefined. And if you think about it, that makes sense because there's a break in the graph here, and there's a break in the graph here. Here is your -1, 0, 1 values to make your curve, and usually we do 2 of these, so that's why there's an undefined between them. Now to make the real graph, alright, so let's look at this. So first of all, we've got to graph it so that you have some on both sides of your axis, and we know we're doing twelfths. So we got to do 3 lines. Bless you. And then we're going to put our vertical asymptotes on our graph first because those are the undefined ones. We got to go from -1 to +1. So we're going to plot our point here at -pi/4, -1, 0, 0. Over pi up 1, and then make like half of a parabola so it kind of hugs these lines that you're making for these vertical asymptotes. Then after you've done your pattern, because this isn't 2 pi, you're going to pattern it off one more time and do it again. Alright, so 3 pi/4. So I patterned it out so that I can plot the same points, so that 3 pi/4 is -1, that this is pi, this is 1, and this is your vertical asymptote. So curve your parabola up, curve your parabola down. Alright, so with this problem, this is the parent function. So now let's look at an example of tangent, maybe with some shifts and different things in it, so we can see how does that change our graph. So first of all, this formula is not in the correct format. So we have to turn this around because subtraction needs turning around, so the x's are first. That would bring a negative out in front of it. So that negative is going to come over here and make it -2 tangent. Also, I'd like to add in a number on the end of this so that we can look at some other types of shifts. So the amplitude is 2. It reflects and it will stretch because 2 is bigger than 1 vertically. Our period is pi divided by 2 because the 2 in front of the x. That's why it was so important to fix that. And then our scale factor is 1/4 of that, so that's an 1/8. Your phase shift is 2x minus pi equal to 0. So x is equal to pi over 2 to the right. And that -3 on the end is down 3. So tangent's supposed to back up 2 lines on the scale factor. So always start in the middle of your table and back up 1/8. 2/8 is a 1/4. 1/8. 2/8 is a 1/4. And then we got to add pi over 2. Pi over 2 to it. And the reason we're adding pi over 2 is because it's going to the right. And you can add these in your head or do whatever it takes for you to do them. But I know the answers already. Now over here we're supposed to put undefined, -1, 0, 1 undefined. We are timesing that by -2 and taking away 3. Times it by -2 and taking away 3. I missed a negative up here. So now we've got to learn how to graph that. So I'm going to pull my paper up so I can graph. So I have a lot of positive, but I'm going by force because you can't do 8s. This is pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. Next one will be 3 pi over 2, 7 pi over 4, and I'm not sure what else I need, so I'll pattern the rest here in a minute. So the first value on my table was undefined at pi over 4. Then I have a bunch of negative values, 1, 2, 3, 4, 5. So I need to pattern that off. And down at 3 pi over 4, I have another asymptote. So I think I drew a little bit too much. So I think I'll erase that. Because here's your next asymptote, because you only have one number in between them. So at 3 pi over 3/8 is halfway between a 1/4 and a 1/2. I'm at -1, at -3, and then I'm at halfway between that 1/2 and 3/4 for -5. It's not straight, so make sure you curve it so it touches the axis. Then do the same thing again and curve it to these dotted lines. So, well, for a problem that looked like it was going to reflect, how do you know? Well, tangent normally goes uphill, and now it's going downhill. Alright, so with cotangent, the amplitude is 1. Again, the period works the same way, so pi divided by 1 is 1. Your scale factor is pi over 4. There's no shift in this one, no reflecting, no stretching, no compressing. The big difference is this one starts with 0 for x, and it's going by force. So knowing which one starts with 0 is important. And over here, the only difference you'll see is that negative switches on which one it's on, because tangent goes uphill and cotangent goes downhill, so they have to decrease in your table. So when you do your graph, 1, 2, 3, pi over 4, 3 pi over 2, 1, 2, 3, 3 pi over 4, 1, 2, 3 pi. Let's start with that. So 0 is a vertical asymptote, pi over 2, pi is a vertical asymptote. I gotta go from -1 to +1. So 1 is pi over 4, 0 is pi over 2, and -1 is 3 pi over 4. So I didn't quite make enough room here to make this graph, but oh well. And then you do that again. And you should number your axis on that as well. You just keep your pattern going with 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So you do the pattern twice, but that's because your period's not 2 pi long, it's only pi. Now let's look at an example that has some numbers in it. So in this one, the amplitude, well, it's a half. Your period is still going to be pi divided by 1 or pi. Your scale factor is going to be pi over 4, but your phase shift is going to be x plus pi over 4 equals 0. So x equals negative pi over 4 makes it go left pi over 4, and then it translates up 1. The half makes it stretch vertically. There's no compression because it's still pi. So here we have to start with 0 and go by our scale factor. And then we have to take away the 4th because we're going to the left. So that comes out negative pi over 4, 0, a 4th, a half, and 3 pi over 4. Over here it's undefined, 1, 0, -1 undefined. So I've got to multiply that by half and add 1. Now let's look at that into the graphic format. Okay, we don't need a lot of negative, but we need a little bit of negative. Because negative pi over 4 is a vertical asymptote. Pi over 4, a half, 3 pi over 4 will be one cycle. 0 is 3 halves, so we're going to need to go by 1 so we can estimate where the halves are. So 0 is 3 halves, puts us here at the y-axis between 1 and 2. Pi over 4 is 1, and a half is a half, and a vertical asymptote over here, 3 pi over 4. So this problem is just like really, really stretched out big in the middle. And then you'll pattern it again. And you plot your points again. I'm not going to number the axis because I feel like you can do that. Just want you to be able to see. It does the same thing again. And you just keep going by force. So you see the pattern here of cycling it twice. Hope this helps you.